I'm Kourtney Chinnery, and I am currently a sophomore at Bridgeway Academy, and I am in AP Calculus. I am in the middle of an 8-part series teaching you different concepts in calculus. This is my third video teaching you the basics of derivatives. My first 2 videos taught how to memorize and use the unit circle in calculus. So, for the third video, the basics of derivatives. A derivative is a fundamental tool in calculus, so it is very important to know how to use the derivative. So, the definition of a derivative. The derivative of a function of a real variable measures the sensitivity to change of a quantity which is determined by another quantity, which simply means a derivative means to calculate the rate of change like a slope. So, several rules to help you to calculate and learn a derivative are, number 1, the derivative or rate of change of a constant number is 0. Because it is a point and not a line connecting 2 points. This basically means that when you are on the xy plane, if you have a number that is on the number line, for instance, on the x-axis we'll use 5, there is no rate of change of that constant number. But if you had another point, for instance 2, you will be able to connect those 2 points and find the rate of change. Now, number 2, for our rules, the derivative of ln of x, which is the natural log of x, equals 1 over x. And that is just another rule to help you remember. Number 3, the derivative of e to the x equals e to the x. And lastly, to revisit the definition of a derivative means to calculate the rate of change like a slope. Now I'll be doing 3 examples to help you to learn and use these rules for finding derivatives. Alright. And we will be using the formula for finding a derivative, which is n times x to the n minus 1. Now, in this formula, n is basically your exponent, and you will take your exponent and you will subtract 1. Then you will bring your exponent down and multiply that times the base number. So, for example, number 1, we will use x to the 5th. So, when we use x to the 5th, this is like x to the n. We have 5, which is our exponent, that is n. So we bring that down and multiply that times the base. So 5 times x, which is basically like n times x. So when we have 5 times x, we will go back up and revisit the exponent. The exponent, remember, is 5, and we will subtract 1. 5 minus 1. And our answer is 5x to the 4th. That is the completion of our first example. For our second example, we will be using 10x squared. So remember, our formula is n times x to the n minus 1. So when we have x squared, this number, we are going to subtract 1 from the exponent. So 10x squared minus 1, which gives us 10x to the 1, which equals 10x. Then, that exponent that we began with, remember we bring that down and multiply it times the base number, which gives us a total of 20x. And that is the completion of our second example. Not too hard. And now for our last example, this will be the longest example. Our last example is 5x to the 4th minus 39x squared plus 10x minus 2. Alright, so a lot of times to help me with the so much subtraction and all the minus signs, I will change it to plus negative, which you know is the same thing as subtracting. So 5x fourth plus negative 39x squared plus 10x plus negative 2. Okay, so I know this looks like a long example, but we're just going to break it down each number at a time and use that formula that we just learned. So we will break down 5x to the fourth. 4 minus 1 is 3. And we'll use that first exponent that we started off with and bring it to the front and multiply it times 4. So for this we get 20x cubed. Then we're going to add negative 39x squared. So 2 minus 1, we're going to take that 2 minus 1, which gives us 1. So remember, x to the 1 is the same thing as x. So right now we basically have negative 39x. So we're going to bring down that first exponent, 2 times negative 39x. Alright, so now we're going to add 10x. So 10x to the 1 minus 1, which gives us x is 0, which means we have no x now. And we're going to bring down our first exponent to the front, which was 1. And now we just have 10. And now we're going to subtract 2. But we can't do that because there is no rate of change, because using that rule, rule number 1, derivative or rate of change of a constant number is 0. So instead of subtracting 2, we're going to subtract 0. So lastly, to finish off the problem, 20x cubed plus negative 39 times 2 is negative 78. Negative 78x plus 10. So overall, our answer to this problem is 20x cubed minus 78x plus 10. Alright, so that is the completion of our video of the basics of derivatives. I hope you understand everything that I was talking about, and I thank you for watching this video. Remember that I'm doing an 8-part series, so I'd love for you to tune into the rest of my videos. Bye!